This example, we're going to take that function, bring it on down here. F of x is 2x cubed minus 36x squared plus 120x plus 6. They're talking about finding local mins, local maxes. How do we do that? We got to take the derivative. Remember, at a local min or max, the first derivative is 0 at either one of those. Right? Remember that? Remember, like if you have a graph and it goes up and has a maximum, if you're riding the roller coaster, here we are, I'm riding, and I get to the top where the max is, I'm flat. My roller coaster has a flat derivative, slope of 0. Remember, first derivative tells you slope. So when the slope, so if you're at the top of, at a maximum, right then the roller coaster is flat slope. You're horizontal. Your f prime is 0. Your slope is 0. And the same thing at a minimum. If you come down here and you're at a minimum, right then you're flat as well, right? You're going here, your slope is really steep. You're going up, or here you're going down. But right at a minimum or right at a maximum, your derivative is 0. Your slope is 0. So if you want to find the minimums and the maximums, you find out where the first derivative is 0. So let's take the first derivative. So bring this down, 6x squared, bring this down, minus 72x to the first, subtract 1 from these powers. 1, bring it down, plus 120, subtract 1, he's gone. The x is gone, and then that's just 0. And then I'm going to set that equal to 0 because I want to find out where does the first derivative equal 0, because that's where you're going to get your mins and your maxes. Well, how do I solve that equation? It's not easy. I would probably divide through by 6 first off. Because notice 6 goes into all of them. That'll just make our numbers easier. We do whatever you do to one side, got to do over here also. It's just going to be 0 though, but still it's helpful. What's that? 12? No, it's not. Yes. Yeah, it is. Yeah, it is. Plus 20 equals 0 over 6 is just 0, huh? It doesn't do anything. Okay. Now, if you're good at factoring, you can just factor that, right? Or you could do the quad. So I'm just going to factor. I'm just going to look at this and go, oh, yeah. Thinking about FOIL, F-O-I-L, remember FOIL? So, front times front to make front, that's x times x. And last in this parenthesis times last in parenthesis to make, what makes 20? What times 20? Well, 4 times 5, but 2 times 10 is going to be better, huh? Because you got to make minus 12. So both negative because minus 2 and minus 10 make minus 12, and they multiply to be positive 20, don't they? So there we go. And then you said each one equal to 0 separately. This one equals 0, or that one equals 0. So then just add, just jump that high, just jump it, jump it. So x is 2, positive 2, right? Or x is positive 10. So I got my two x values. So those are the places where we're going to have mins and maxes. Well, how do you know which one's a min, which one's a max? You got to do a number line. So I'm going to come on down here and I'm going to do a number line. I'm going to put just those on there. 2 comes before 10, so I'm going to put 2. I'm going to put 10. In fact, what I'm going to do is just make a big old space here, probably more than we need. Oops, hit it a little better straight line than that. Hey, why is that thing doing a straight line for me? Hello, straight line maker. I want a straight line. There we go. All right. So what I'm gonna do now, I'm gonna check. So 2 and 10 are either mins or max. How do I know which is which? Well, I'm gonna check some point to the left of 2, like 1. I'm gonna check 1. Check some point between them, like how about 3 or 5 or 6 or 7, whatever. And some point to the right, like how about 11? Whoops. Wait, what did I do? Here, I'll do a 3 and I'll write check. And I'll do like 11. All right, check. So you're checking in between, in the left, in the middle, and in the right, between these two critical values to find out if they're maxes or mins. Checking what? Checking the first derivative. So I'm going to go back to the first derivative. Here it is. In fact, here's the first derivative right there. 6x squared minus, I'm going to check that. 6x squared minus 72x plus 120. So f prime is 6x squared minus 72x plus 120, is that right? Yeah. So that's the first derivative. So I'm gonna plug the 1 into that. I'm going to find out what is the derivative at 1. Remember, because the derivative tells me the slope, right? So let me plug it in. I'm going to go to Desmos. 6x squared minus 72x plus 120. So 6, it's 1 squared minus 72 times 1 plus 120, right? 6x squared minus 72x plus 120. 6x squared minus 72x plus 120. Plug it in 1. Yeah, looks good. Okay, so what did I get? I got 54. So positive 54. So that means positive 54, which means the graph is going up in that section. So the graph must be going up in this section. I know because the slope is positive. You might say, well, only at 1. Well, no. I know at 2, the derivative is 0, right? That's what I found. That was what I did in the first step. I found where the derivative is 0. So the derivative is 0 here and 0 here. Everywhere else, it's not 0. So in this section, if it's positive in one place, it's positive everywhere in that section. So the graph is going up in that section. How about in the middle? Now I'm gonna do it again, and I'm gonna plug into again. F prime is same thing. Plug into that first derivative again. I'm gonna grab that 3. I'm gonna plug in a 3 now, and find out what the derivative, the slope, is in that section. This time I'm plugging in a 3. So just go back, Desmos, change that 1 to a 3. That's why Desmos is so nice. Boom, what do we get? Negative 42. Negative 42. So it's negative 42. So the graph is going down in that section because the slope is negative. Okay, last one, I'm going to plug in, what am I going to plug in? I'm going to plug in to the derivative again. 6x squared minus 72x plus 120. I'm going to plug the 11 in. Boom, boom. Or anything to the right of 10. So let's plug in an 11. Go back, change that 3 to an 11. Change that other 3 to an 11. What did I get? Positive 54. Funny, same thing I got before. Slope, derivative, positive. There mean the function's going up. So in other words, what we've learned is here's how the graph goes. The graph goes up in this section, down in this section, and up in this section, right? So this must be a local max. And this must be a local min. So 2 is a local max, and 10 is a local min. I found out what those critical values are by finding out what the function's doing up or down by looking at the first derivative. It tells me the slope in those sections. So there we go. So, oh, and they don't have the y values? Yeah, function has a local minimum at x equals 10, right? 10 is the minimum, right? 10 over here. Local min at 10. Oh, output value, got to get that. And maximum at x is 2, right? Now, how do you get output value? Output, you got to plug into the original function. So I got to plug in, when it says output, it means height, what comes out of this function. So I got to plug into that function. I got to plug in 10, and then I got to plug in 2. So let's go do that. So the function is 2x cubed minus 36x squared. So 2x cubed, 2, 10 cubed minus 30, minus 36, 36. Oops, I'm trouble here. 10 squared. 2x cubed, what was it? 2x cubed minus 36 squared plus 120x plus 6. Plus 120x plus 6. Plus 120x plus 6. There we go. I got negative 394. Is that what they got? Yep, negative 394. Now that was when I plugged in 10. Now I'm going to plug in 2. Hopefully I'll get 118. Go back and change it to 2. So my Desmos again is so nice. You just change the plugin that quick. Let the computer do the grind work, and you do the thinking. That's how it should work, right? And 118, there it is, beautiful. And so we got it. We got the output values. And there we go. We learned about what that's graph doing. Last thing, let me prove that what we just found is really the truth. If you look at this thing on a graph real quick, let me just type it in. If you go to the Desmos grapher, which you cannot do during an exam. But it's fun just to check right now. Let me do this. Let me come up here and get rid of what I just had in there. And we got 2x cubed, so 2x to the third, minus 36x squared, minus 36x squared, um, what? Plus 120x plus 6, plus 120x plus 6. No, that's not 6. 6. I always like to see, okay, there's the actual graph. Okay. Let me shrink it sideways a little bit. Here we go. All right, so there's, let me take a picture of it. There's the actual graph that we just found. There's what we thought it would look like, right? Let me put it in here where we can see it. Desmos note program's having a little trouble here. Good notes. Come on, good notes. How are we doing? There you go. All right, here's the graph we got. So how does it compare to what we predicted? We said it would go up to, what is it, 2 and then down to 10. Yep, look at that. It's beautiful. Up to 2, there's the local max. Down to 10, local min. Yep, and this is up like around, it's like around 100 or whatever, and this is down at like 400. Yeah, looks good. Right? It's going up, going down, going up. So we're able to basically figure out what the graph looks like from just doing what? Taking the derivative. You take the derivative, you set it equals 0. You find the places where the derivative is 0. You found the critical places that are maxes and the mins. Then you just check in between them with the derivative again, find out if it's going up or down or what. And you know what the graph generally looks like. The power of derivatives. There we go.